Friends, welcome to the new video of free engineering tutorials on operating systems. In previous video we had discussed about system boot and processes. In this video we will be talking about threads. So till now what we have discussed are single thread executions or single thread processors or single thread computer systems. So what do we mean by single thread? So single thread means at one time only one process will execute. At simultaneously, no two processes can execute. Like we are writing a Word document and at the same time we are checking for our grammatical errors. It can't happen in single thread operating system. So for that we have to implement multi-programming. What multi-programming gives us the advantage of running at least one process at all times. So the definition is, for process scheduling, objective of multi-programming is to have some process running at all times. As I have told you, we have to run at least one process at all times. If it will not happen, then our CPU cycles will be wasted. So the objective of time sharing, so for scheduling we have to implement time sharing between different processes. So time sharing is to switch the CPU among process so frequent that users can interact with each program while it is running. So it basically gives us a sense of running two processes at the same time. In reality, no two processes are running at the same time. Only one process is running at one amount of time or one instant of time. So process scheduler selects an available process for program execution on the CPU and it will execute that process at that instant of time. So how threads work is that let's suppose there is a process P0 and process P1 and P0 is already executing. Now if an interrupt occurs and it is saving its state to process control block, and it will save its state and handle over the control to the process 1. So it will reload state from process control block. This process control block, that is PCB, is just a table which will store the different type of processes and their addresses. Okay, so at this point of time you just understand PCB as a table, and from that it will reload state from PCB1. So this P1 will come into existence and it will execute. After that, if another interrupt occurs, so it will hand its control again to the process 0. So for that it has to save its state or current state to the PCB1, and it will then again reload the P0, means process 0 state, to the processor, and now P0 will start executing. So in this way multi-threading works. So now we will be talking about scheduling queues. So there are two types of scheduling queues. One is ready queue, another one is device queue. So in ready queue, while entering in the system, processes are the part in job queue. These are the parts of job queue. So for different processes, or we can say if there are many processes which are coming or which are interested to share the resources, so we have to keep a queue, waiting queue for that, and we have to store different processes in it. So this is known as a ready queue. So it's just like an entrance gate of a building. Okay, and what do we mean by device queue is that if a process is already running in the memory and it has to wait for the input or output coming from any device or going to the device, so if for that it has to wait, so it is called device queue. Because of waiting for the device, its name is called device queue, and thus new process has to wait in device queue present in the disk. So process will present in the disk. process can do several tasks. So while running, it can have certain privileges that it can do different type of tasks. What it can do is that it can issue input output requests for any data, for output, for giving output or taking input. It can issue requests for different devices, and it could create a new sub process, means it can create sub child process and wait for its termination, and it can directly remove its child processes or process from the execution and come it to the ready state. So this privilege is also process is having at the time of execution, means pull over from the state of execution to the ready state. So there are two types of schedulers. One is long term scheduler and second one is short term scheduler. In long term scheduler, which is also known as job scheduler, it selects processes from the pool. So there is a pool of processes from which we have to select one and has to execute. So this is done by long term scheduler, means LTS. And for short term scheduler, like we have to wait for the input and output devices to take the input or to give the input to the for the output. So this is done by STS, means short term scheduler. So there are two types, one is LTS and the second one is STS. So talking about LTS, so it will execute much less frequently, because input and output data a process has to take frequently, so it will be done by STS. And for LTS, it is much less frequently because it will take time, and minutes may separate the creation. So between two LTS there may be a separation of minutes too, and creation of one new process, and the next LTS controls the degree of programming. So it also controls, because for the degree of programming means how many processes can execute at an amount of for an amount of time. So it can be controlled by LTS. Generally, most processes can be described as either input output bound, because they are bounded by input output devices and has to depend on the devices for the input or output. An input output bound process is one that spends more of its time doing an input output operation. Like if we are writing our C program for giving the input, for taking the input and has to execute, and after execution whatever the result we have to give the output. So this is called input output bound process, because in the program there are certain processes which we have to execute. That processes are called input output bound process. So these are the 5 points which we were talking. Like firstly, the process has to wait at the entrance gate, which is ready queue. After ready queue, when the process is ready to execute, it will go to CPU with certain amount of registers and memory. Now at the time of execution, it can do several things, like it can request input output data or input output request for different devices. So for that it has to wait in input output queue. After that input output queue, if one process is selected by the scheduler, then it will got input output data, and again it will come to the ready queue. In the second scenario, it can also time slice. If the time slice is expired for any process, it will directly go to ready queue. Means time slice expired means if the time is provided to any process but it hasn't executed at that time, then again when the time slice ends, it will directly go to ready queue. It can also divides itself into a parent and a child. So forking a child means it will create a new process which is called as child process. So then after execution of child process, when it terminates, it gives some result. After getting the result, it will again go to ready queue. So at this amount of time, when child process is executing, that parent process has to wait for its result. After that, it can also wait for any interrupts to happen. After interrupt occurs, it can go to ready queue. So this is the explanation of this diagram. So now we will be talking about what is the context switch. In previous slides, once I had mentioned what is the context switch. So context switch is basically handling over the control which current process is executing to the next process which is waiting in the ready queue or input output device queue. So whatever the process which is waiting in the queue, handling over all the resources or present state to any other process is called context switch. So formal definition is, when an interrupt occurs, system needs to save the current state. So before context switch, the current process which is executing has to save its state. In process control block, it can save its contents, and after execution of different process, it can reload its contents from the PCB. So context of the process currently running on the CPU, so that it can restore that context. So that is what I'm talking about from the that we can reload the contents from PCB. So this is called state restore, and the switching between context, save state and state restore between process is called context switch. So this whole process is called context switch. It is highly dependent on hardware support. Now there are certain operations on processes, like the root process is known as sked process. It can bifurcate itself into different type of process like init, page out, fs flush. So this fs flush and one more page out is, these are two type of processes which are very important in operating system. These are responsible for managing memory and file system. So as you can see, these divide means parent process can divide itself on the basis of process ID, and it forms a tree like structure. So yeah, that's all. So in next video we will be talking about a program on which is based on operation of on processes. So till then, thank you.